Hello, everyone. Thank you for another episode of Brute Facts joining us. I'm glad everybody's here. Took a little time off. It's been a couple of weeks, but got a nice lineup coming up. But first, tonight, we have Dr. Luke Barnes, who's a favorite of mine. He is well known for the fine tuning argument. It's his is not as I guess high level contemporary. It's pretty technical and deep. We won't be going really deep into any of that tonight. Just learning more about him. Dr. Luke Barnes is a lecturer at Western Sydney, Australia. He's down on the bottom side of the planet. I guess he's top of the planet, or to us. So. He also has a PhD from Columbia. So I'm excited to talk to Dr. Luke Barnes and ready to get this party started. Hello, Dr. Barnes. How are you doing?
I'm doing very well. Thanks for having me.
Yeah, I really appreciate you coming on.
Yeah, it's good to be here. I went to Cambridge, not Columbia, by the way.
Oh my gosh, Cambridge. That's yep. I'm sorry.
Started with C. That's close enough.
It's I even had it written down and still said the wrong thing.
As long as you don't say Oxford, that's the main thing.
That's it. Oh yeah, that'd be like cuss words, wouldn't it? So tell us a little bit about yourself.
Yeah, so I'm an astrophysicist, a cosmologist by sort of training and profession. I'm a lecturer at Western Sydney University. So yeah, I'm currently in Sydney, Australia. Whether we're at the top or the bottom is up for debate, but I'm sure we can nut that one out. Yeah, so one of the research fields that I have looked into as part of my career is this thing called the fine-tuning of the universe for life. Just what's the connection between the fundamental properties of the universe around us and life as we know it, or even as we could imagine it out in the universe.
All right, awesome. Yeah, that's so you've written or co-written a couple of books on that. I'm sorry, go ahead.
Well, they're conveniently behind me. Yeah, the books.
Oh, convenient.
Yeah, so a Fortunate Universe, both co-written with Geraint Lewis, who's a professor of astrophysics at the University of Sydney.
So, looking through your information and everything, you have like 5 different titles. What do you call yourself? Are you an astronomer, astrophysicist, cosmologist?
So yeah, the sort of the lines are a bit blurry, and it's one of the things I'm interested in is precisely where the lines do get blurry. So so very simply, an astronomer, I think, is the most obvious one, where you look up at you're trying to understand the things out there in the universe. I'm not an observer, though. So astronomy roughly divides into, there's the people who do the theory, there's the people who do the observations, and there's the people who build the instruments themselves. Who sort of, I'm definitely not. I'm over on the theory side. So I guess astrophysics, but my interests are using sort of our theories of the theories of physics to try to understand the universe as a whole. And so it's sort of the use of astrophysics to understand cosmology. So it makes me a cosmologist as well. It's precisely where those fields blend together that I'm interested.
Okay. Okay. So I got to ask, there seems to be, at least on the popular level, a rift between in general physics, theoretical physics, and physicists. Do you face the same thing as in astronomy, as the theoretical versus the, um, I guess,
Well,
the
yeah, we'd say the
practicing?
observational.
Yeah,
Yeah, in other fields it would be the experimental versus the theoretical. But
experimental.
yeah,
I
we
was
don't. Yeah, we don't say experimental because we don't we don't really do experiments so much.
right.
So observers. Well, it's everyone has to talk to everyone else. It's just a very different set of skills
Yeah,
that you'll specialize in. So, for example, my particular set of skills involves being able to run computer simulations and supercomputer simulations of how galaxies form and various things like that. How light moves through galaxies was what I did my PhD on. And so that involves a very specific set of skills. Other people will specialize in using telescopes and analyzing the data from telescopes and getting the most out of that and planning out observational, runs and all those sorts of things. There's an overlap. I sort of have done some of one side, at least the sort of data analysis side of things. I know roughly, an awful lot about how to do that without being a specialist in that. And obviously, everyone in science knows how to code these days, of course. And so there'll be some understanding of how to do simulations from, at least at some level, even from observers. So it's really a question of specialization rather than, two very distinct communities.
Right. And you are a Christian.
I am indeed. Yep.
Were you raised religious in any kind of way, or?
Yeah, so I was raised in a Christian family here in Australia. My dad's a Presbyterian pastor here in Australia. So I was raised in a Christian household and grew up in that. No sort of major break in that. I didn't sort of drift away and come back to the faith. Sort of being fairly constant churchgoer, if you want to sort of put that sort of metric on things. For my whole life. So, yeah.
So, obviously, there's not an overwhelmingly, or statistically speaking, theists in the sciences. So, how does your colleagues? I mean, is that something that ever comes up, or?
It does. It's not like I'm, the only one. I think it's less than the average population, but there's still. I mean, even Australia, which is more secular than the US, so far as I understand it, there's still it's still a large fraction of people, maybe 50-50, who will say that they believe in some sort of God. That fraction will be is I think lower in the sciences, but it's not like it's 0.5% or something. And so I know even in Australia, plenty of Christians who are sort of in the field of astronomy, in the field of physics. So yeah, occasionally it comes up when you're down, not usually not during office hours, but if you're out, getting dinner with people afterwards at a conference or something, you have a chat about all those sorts of things, as you chat about every sort of thing.
Yeah.
Generally there's, and I'm rarely the only sort of believer there. So, yeah.
Yeah, that's a bit promising. So coming up with the fine tuning, do you ever get accused of mixing your religion with science, or is that something that you've heard any pushback on? Or?
So one of the things that actually turned out to be a sort of, it almost wasn't planned this way, but it turned out quite nice. So my co-author for A Fortunate Universe is Geraint Lewis, as I said before. He was my honors supervisor and my master's supervisor. And then I worked with him when I got a postdoc back in Sydney in around 2011. He's sort of, more senior than me in astronomical circles and quite well known. So he's also an atheist. So the way it sort of came about with was I had written a sort of review article of the fine-tuning literature in the scientific literature and had published that. And then I did a talk to just the Sydney Institute for Astronomy, which just is all the astronomers at Sydney University. And that was quite fascinating, actually, because it's just some interesting science, and you can then, we can all have a chat about the implications afterwards. So I gave a sort of 40-minute talk, which is the standard length of a seminar. And usually you have like 5 minutes of questions after that, and then everyone goes to lunch. But this one, the questions, everyone was like chatting about this for like an hour and a half. And that's, I've never seen it before or since in astronomy seminar, which was kind of cool. But out of that, he sort of knew I had an interest in this. He'd read some of the, he'd read the review article, but he at the same time was looking to write a book on something, and suggested we write that book together, which was a really great idea that I'm fantastically thankful for. What it does is I can say that the first 7 chapters of the book were written together between a Christian and an atheist, and it's the science we agree on, with the exception, I think, of one footnote, which people can go and find. And then chapter 8, we discuss about what this all means, and that's where we have our, back and forth. It's written like a conversation. But that I think the fact that it's also published by Cambridge University Press just puts the brakes on any accusation that this is just, theistic. So just some Christians just made this stuff up.
Yeah. It's kind of, being a fan of it myself, that's kind of one of the things that I hear a lot is, how does that mean? How do you get to God? How do you get to God? Why couldn't it just be chance, and things like that? And I'm like, have you ever read Dr. Luke Barnes' work? He addresses all of that. So what got you into astronomy in general? What was your inspiration for that?
So it was a bit of a roundabout way, actually. So I was good at maths, or math, depending on where your listeners are from. I was good at that in high school, and as part of that, then chose my sort of last 2 years of high school, what is for us year 11 and 12, chose physics because that would sort of play into that strength to get sort of good marks, and it seemed pretty interesting to me anyway. And I found that was really fascinating that you can use mathematics to understand the real world. And then out of that, wasn't quite sure what I wanted to do in university. When you're a bit of a nerd, everyone assumes you'll either be a doctor or a lawyer. And I almost did law, and I think that wouldn't have been such a bad outcome. I was never going to be a doctor because I can't even stand watching a medical show on the TV, let alone getting my hands in there. But then sort of looked through all the subjects that I'd done at high school and realized that actually this physics stuff was the stuff I was really interested in. And so I did my undergraduate degree in that. As part of that, then sort of discovered that actually cosmology is absolutely fascinating. Found a really wonderful textbook on cosmology called Cosmology, The Science of the Universe by Edward Harrison, which was one of those, this, I want to do this, please, forever. As part of that, then, cosmology is sort of subsumed under physics and under astronomy. So that sort of then moved me. So I went to the biggest scale of the universe, and then sort of you then have to start worrying about things on the smaller scale. If you want to understand what the universe as a whole is doing, you need to understand what sort of things are out there in the universe, and then that leads you into sort of astronomy.
Yeah. I was just kind of wondering if it was one of those little kid moments looking at the stars, I'm going to go to space one day. And
I was a dinosaur nerd.
Oh,
my grandma tells the story that she was in. They'd taken me into some museum and where there was sort of bones of dinosaurs, and I have no memory of this, but asked some ridiculously technical question of whoever happened to be there, and they sort of gave me a blank look. So yeah, it's all set up for me being a sort of paleontologist, but it's not not what I got into. So yeah, the physics, the astronomy, all of that specifically came a bit later in life.
Yeah, and turns out you're a pretty good cello player too.
Well, that is highly debatable. No, I took up the cello about 5 years ago. I still take lessons. It's sort of seems a very tame midlife crisis, I suppose. It's a fascinating instrument. The difference between the way I play and my teacher plays is one of the things that keeps driving me forward. So he plays and sort of angels start singing, and then I play and a cat starts wailing. Yeah.
Anyway. I'm actually
I'm
a fan. I mean, I like music altogether. I'm really ADHD, so I'm very analytical about some things, and then the next minute I want to be, artistic, and so I'm kind of all over the place. But I love music. That's been a staple for a long time. So, did you play bass in a band, or?
Oh, look! How have you turned that? The bass guitar is right there, in the edge of my screen. If people can see that, that's how you. Yeah, okay, yeah. So when I finished high school, actually no, first year of university, for some reason I don't fully remember. I was like, I'm going to learn the bass guitar, and went out and got like a cheapo bass and a practice amp, which is still just down there. And then 5 months later, I loved the sort of third wave ska music, Mighty Mighty Boss Tones, Less Than Jake.
Yeah.
And my sister had a friend from school who had a ska band who was looking for a bass player. I'm like, well, I'm going for this. I don't care if I'm terrible. And they put up with me for long enough for me to get good enough to be all right. And so I was in a ska band for 4 years while I was at university. And that was the most fun I've ever had. It was fantastic. And I would run away and join a ska band in a second.
It's crazy how, you meet so many different people in academia, and then you find out they have these little hidden talents and, other passions that they would leave their work for in a moment, to pursue.
I don't know if the wife would be happy with me running away joining a ska band, but I'd be happy as Larry. Yep.
Well, a few more books, maybe get on a bestsellers list, and you have free time, do what you want.
The great so Brian May, the guitarist from Queen, has a PhD in astrophysics. So he is sort of the patron saint of astrophysicists.
Wow, I didn't know that.
Who secretly want to be rock stars. He was sort of 3/4 of the way through when Queen took off, and so abandoned it. But all those years later, I think it was about 10 years ago, then some colleagues who were I think it was at University College London, I should probably look that up, were like, your project's still pretty good. If you polish this up, we'd be able to give you a PhD for this. And so he was like, yep, fine. And so, Dr. Brian May, astrophysicist.
Wow. That's crazy. That's, I just recently learned, I've been doing some reading into comparative religions and Zoroastrianism, that Freddie Mercury was a Zoroastrian.
Okay.
Yeah, and I was like, what? That's just not something I ever heard. I think it was more of the mystical offshoot of Hinduism or somehow tied into Hinduism that he was. So yeah, a man of multiple talents. So when are you going to put together a presentation that includes the cello or bass guitar along with it?
I think for the cello, I'm a while off. Rather difficult instrument. No one wants to hear a solo bass guitar though, unless you're extremely good at it.
Hey man, I've heard some crazy bass solos.
If you're Victor Wooten, sure.
Yeah.
But the rest of us, not really.
Yeah, I grew up in Memphis, Tennessee, where Elvis is from, and there's a huge local music scene there. And I had friends that were in bands and stuff, and some of the bassists that they had. I was like, who wants to play a bass guitar? And then I heard them guys go at it, man, and kind of funk style, and they just, yeah, I was like, yeah, I could do that. So I did it for about 5 minutes and moved on.
Well, this is what I discovered when you pick up the bass guitar. So for me, it was about the year 2001. So the internet was around enough for me to go like, who are the best bass guitarists? Put that into the internet, and a whole bunch of names come up that you've never heard of, and so you start looking into it. Jaco Pastorius and a whole bunch of those. But you quickly discover that all the greatest bass lines are in funk.
Yes,
like just all the most awesome. James Jamerson just did everything in the 60s and 70s. If you learn all of those, that's it. That's your apprenticeship as a bass player.
That's you get the good popping with it, and it's definitely the genre meant for a bass guitar for sure. So, so you do work on multiverse, quite a few different areas. What is your interest in? Other than being an astrophysicist, the multiverse hypothesis. I mean, is that something that's gaining ground? Is it getting more popular?
It's hard to know whether it's gaining ground as such. I think so. The multiverse is this idea that, okay, we look around us and we look at the properties of the universe around us, and we see that, for example, it's made out of protons and neutrons and electrons. But every electron we've ever found has, for example, the same property. So the same mass, for example. They're all the same mass as each other. And so you start to wonder about, why that mass rather than some other mass, relative to other particles. And if you think through all of that sort of stuff, you start to think, okay, then fine-tuning comes in and says, well, if it had been a slightly different mass this way or that way, a lot of the complexity that life as we know it relies on, or life as we can imagine it relies on, would go away. That various things in our universe that stick together would then fail to stick together if you change that number by a little bit. So why is that the case? Well, maybe, and you could get to this thought independently of fine-tuning, but maybe what we think of as a fixed property of electrons, there's just this little label that's stuck on every electron that just says the mass, and all the labels are the same. Maybe it's actually not a little label. Maybe it's some other. It's a dynamic property of the universe. It's something that changes from that is actually able to change from place to place. It's not a fixed static label. Maybe it's the same everywhere around here for the same reason that the air in this room has the same temperature everywhere. It's just a local property of the conditions we have around here. So maybe if we looked far enough away in the universe, we would find, for whatever reason, electrons that have a different mass. They're a bit heavier over there, they're a bit lighter over there, and all that sort of stuff. The thought is that might help explain why a life-permitting universe exists at all, because the universe basically tries all the combinations of stuff until a life-permitting one turns up somewhere. So the thought is then, what if we have this, if we've reached the end of our explanations in sort of the standard, picture of what the universe is made of that we know about, electrons with a certain mass, what might be the next step? And the next step might be not that we have some explanation of this specific number, but actually that this number is just a product of our local environment that would actually be different somewhere else. So that leads you in the direction of the multiverse. If my interest in this comes from trying to treat that as a scientific idea. There's all sorts of philosophical arguments about whether it is a scientific idea, right. But you can, to some extent, treat it as a scientific idea. If someone produces, as always, as a physicist, I want someone to produce a model, by which I mean a mathematically precise idea about how the whole thing fits together. So, if I had a model of the population of the world and their ages and all that sort of stuff. I want to be able to ask that model questions. I want it to tell me about all that sort of stuff. So if there's a model of the multiverse, I want it to tell me, what other values of the electron might I find out there, and how common, in some sense, by some measure, is this value or that value? Are values like ours very rare or very common, or are they big bits of the universe with really heavy electrons and only very tiny bits of the universe where the electron mass is very small? I want all of that sort of stuff to be answered by a model. Once you've got something like that, you can then ask, okay, given that sense of the population of universes out there, where does our universe sit in that population? So if if you had that model for all the people on Earth and all of their ages, you could then ask, okay, where am I in relation to that? I'm sort of roughly in the middle, and where's my 8-year-old? He's sort of over on this side. How many people are younger than my son, and how many people are older than my dad, and all those sorts of questions. The multiverse is supposed to be that sort of idea.
Yeah, that's but it seems like it it may solve the fine-tuning issue, or a possible beginning of the universe or something like that, but it still seems to have quite a few philosophical implications, which I'm sure you're familiar with. Where did the multiverses come from?
Sure.
So we kind of seem, philosophically just kind of pushing the goalposts back a little bit.
Well, I would say that actually no scientific theory can address the question of why is there a physical universe at all?
Right.
It's just not the right sort of thing to ever answer that question. It's not a failure of a scientific theory to fail to do that. Any more than the fact that my laptop can't, drive along a road is a failure of the laptop. It's just not that sort of thing. In any scientific theory, you start off with, what if the universe was like this? And then you derive predictions from that. Well, if the universe was like that, then we'd expect to see this. And then you go and see whether this is actually out there. So if you have some theory about the way that light scatters off various elements, and a theory about what elements are up in the atmosphere, at the top of the atmosphere, you might ask, okay, well, if the sun shone on the atmosphere during the day, what color would it look like? Okay, and if your model, when you go and work in your little world and you draw out all the implications of what you think the world is like, and it comes back that the color of the sky during the day should be purple, then you need to go back to the drawing board and start again, right? Because it's not purple, it's blue. All right. Okay. Right. Sorry. We'll go through all of that. So, if that's the case, if you always start with what if the universe was like this, then there's no way you'll ever get an answer to why is there a universe at all. You're just not in the ballpark of that question. And it's no criticism of science to say you're not. I think the best sort of naturalist thinkers along these lines get this point. And so they'll simply say a question like, why is there a physical universe at all, is just one that we'll never get an answer to. There is no answer to, or we'll never get an answer to, or something like that. It's not,
or it doesn't matter.
Yeah.
Yeah.
They'll say something like, oh, you don't get answers to all the questions that you want answers to. Why should the universe answer all your questions? At some point, you've just got to give you can't even really give a reason for it. At some point, you just have to ignore that question. But what you don't say, what we certainly shouldn't say is that, we're just waiting for science to get the right sort of theory that will answer that question. So that's not going to happen.
Yeah, that's that. And here at, the popular level, that's something I run into a lot, is it's trying to get people to understand, one, that science is a method, and it's exclusive to the physical, and if there are metaphysical things, it's just not a tool that can investigate these metaphysical things. It's not going to tell us why there's something rather than nothing, why we love why we may be able to investigate the mechanisms, the building blocks, and things like that. But ultimately, it's not going to give us the why question. And then I have to caveat that with, I'm not attacking science. I love science. It's just limited. I mean, it teaches us everything that we need to know about the observable physical reality that we live in, or hopefully eventually. But it's just it's not in the realm of being able to address those things.
Yeah. So then getting back to the multiverse idea, there are some ideas of the multiverse which are sort of non-scientific and metaphysical, you might say. But the difference for me between them is, I know what I do with a physics theory when someone hands it to me. I try to get predictions out of it. And so the sort of multiverse where you say, everything exists somewhere, everything out there is, just some sort of, there just is a whole bunch of universes out there. I can't do a whole lot with that. Whereas if you actually try to put some sort of bones on the skeleton and, flesh on the skeleton, I should say, get the metaphor right, and actually give a mechanism for how these universes might be generated, different bits of the universe with different properties, then I can maybe start to get my physics mitts into it and to see what's going on.
Yeah, it's definitely an interesting topic, and it's funny. As soon as you said models, I immediately thought of Sean Carroll, because back when he had his Craig debate, and he said, "Well, we'll just make models, and we'll make more models, and then we'll make more models." But you were actually on his podcast. That was a fantastic talk, man. I really enjoyed listening to you guys talk.
Oh, we're on Unbelievable with Justin Brierley together.
Yeah.
That was a good chat.
I'm sorry. Yeah, not his podcast. Sean
he
Carroll
has quite a good podcast. I think called, I want to say, Mindscape. Anyway,
Mindscape. Yeah,
there's some very good chats there.
Yes.
But no, I wasn't on that. I was on the
Unbelievable. Yeah.
Unbelievable with Justin Brierley.
I listen to so many, I get them mixed up.
So. Yeah, me too.
So how'd you enjoy that? It was pretty interesting.
It's always a bit too quick. I mean, I've met Sean before in a couple of different places. He for me is philosophically just a level or two or seven above a bunch of other physicists and cosmologists who sort of blunder into philosophical debate without really trying to understand what's going on.
Right.
So the classic is Why Is There Something Rather Than Nothing by Lawrence Krauss, On Being by Peter Atkins, and reading those, it's just they just haven't got a handle on what the philosophical problem is to then start to understand what the answer should be within their own worldview. So Peter Atkins is particularly one who's put forward this, all these philosophical questions, we're just waiting for science to make enough progress to answer them. Whereas for Sean Carroll, he understands the problem enough to know what the answer needs to be within naturalism and then try to defend that answer, as we were saying before. The answer's got to be something like, well, not all questions have answers. It would be nice if, you might think it's nice. It would be nice if there was an answer to the question, why is there something rather than nothing? But maybe reality just doesn't provide that. And if that's the simplest and best hypothesis in some way, then that's just what we should go with rather than trying to shoehorn in some explanation from somewhere else. I should say his book, I think, is behind me somewhere. The Big Picture is somewhere there. Anyway, is where he lays that out.
Yeah. I love Sean Carroll. He's one of my favorite naturalist physicists or theoretical physicist. He's because he does at least, go into the philosophical part of it. I think he realizes more, and this is not a knock against, the other professionals, but he's not afraid to get his, hands dirty in philosophy while talking about these things. And a lot of them seem to want to kind of stay as far away from philosophy as they can.
Well, they say they want to stay away from philosophy, and then they do philosophy badly whilst thinking that they're just doing science.
Right.
You want to put it that way. So they're in a philosophical realm, but they don't realize that they are.
Right.
So they think they're just doing science, but actually they're just doing philosophy badly. So a good example of this was, one of the reasons I like Sean, and there's a number of other sort of people on the edge of philosophy and physics who are, I would say David Albert, Barry Lower, Tim Maudlin, Craig Callender, a bunch of people who are sort of right on the boundary of philosophy and physics, who are just worth listening to on whatever topic they want to have a chat about, whether they're right or not, that they're worth understanding.
Yeah.
Is you get to the interesting questions quickly. So with Sean, you're not going to waste time about whether science can answer that question or not. You're going to keep asking the question. You get to the root of the issue, which is, do I have a right to expect an answer to the question, why is there something rather than nothing? Whereas I've seen discussions with, actually I was there in Sydney when William Lane Craig had a discussion with Lawrence Krauss. And Craig's opening statement, it was on this question, why is there something rather than nothing? It had to do things like try to explain what the word nothing means, just in the sense that it's used in the question, why is there something rather than nothing? It's a term of negation. It means not anything. It's not a type of something that we have labeled nothing. And it was sort of an exercise in reading the dictionary, and it still didn't twig with Krauss that what was going on. It was such a basic and simple and straightforward point, and that Krauss still came in with his shtick at that time about, science is able to redefine old questions, and it's just no, it doesn't.
Yeah,
if you want to ask a different question, fine, but then don't call your book Something from Nothing.
That's that was my thing when I learned that Krauss had said, we know that there was nothing. We know what that nothing is, but that nothing still contains fundamental particles and quantum vacuums and fields and it's like, wait a minute, that's not the philosophical nothing. That's not, when people say something rather than nothing, they're not talking about an empty space where there's actually things. You still have the space. It's not that kind of nothing. So that was a cringe moment. Speaking of that, what are some, just off the top of your head, some of the worst objections that you've had to the fine-tuning argument?
So actually, chapter 7 of the book just goes through a whole bunch of different reactions that we get.
Right.
It's always a lot of fun. So one of the things I quite like is actually a great illustration of this. I was in New Zealand giving some talks, and one of them was to a group called Skeptics in the Pub, who are a great group, get together, have a chat about all these sorts of things. Great stuff. So I gave my usual spiel about this. I can present all the science, and then I say, if you want to read more, it's in the book. By the way, it's co-written with an atheist, so that disarms the immediate, this is just some stuff made up by Christians argument. But then there's all sorts of responses to fine-tuning from the audience. But the interesting thing is that someone over here would present a response, and then someone over here would jump up and try to refute it. And so actually the audience started arguing with itself, which was just beautiful to watch. It's fascinating because everyone sort of has an opinion immediately, but no two people have the same opinion. There's a whole bunch of people. Every time someone says to me, it's obvious what the flaw in the fine-tuning argument is, I have no idea what they're going to say next. Because there's this whole host of things that I get back. I guess, there's a bunch that just for me don't get off the ground. Maybe it's just a coincidence. oh, it's just a fine tuning in our models, not in the universe itself. That doesn't make any sense at all. The whole point of fine tuning is that it compares the way our universe is to a bunch of ways that it could be. And so pointing out that the ways the universe could be are just ways that the universe could be is the whole point of the argument. So that one just, there are some that just fundamentally misunderstand the argument itself or fine tuning itself. What else? There's the puddle analogy, about which I've done a number of things. So there's an article I wrote with Geraint. I think it was called The Anthropic Principle, a User's Guide. The trouble with puddle thinking, something like that. And a bunch of videos with various other people on YouTube. I'm sure you can find that. The problem with the puddle, let me explain that quickly. So some people will just say the puddle analogy. There's a quote from Douglas Adams, who was the author of Hitchhiker's Guide to the Galaxy, which is just over there on my bookshelf. Wonderful book. Who said, and roughly says, imagine a puddle who is thinking, oh, this hole that I'm in fits me perfectly well. It's really, really good. In fact, it must have been perfectly made for me. And the puddle continues to think this even as they're shrinking under the sunlight. They still think, well, this hole was made perfectly for me, so it must be meant to have me in it. The problem is with that response is, at most, all it says is, okay, just be careful with fine-tuning arguments. There might be an alternative explanation out there you haven't thought of. And yeah, fine. What alternative explanation did you have in mind? I mean, for the puddle, the explanation for why the shape of the puddle is the same as the shape of the hole is because there isn't really such a thing as the shape of a puddle. Puddle's a liquid. It'll just fill whatever liquid it's in.
Right.
Whatever hole it's in. In the case of, that's supposed to be, I assume, analogous for the requirements for life and the properties of our universe, that our universe and those two things fit together perfectly. But there's nothing in that equation with life and the universe which is sort of analogous to a fluid which will just do whatever. I mean, if the allegation is that life will just fit into whatever universe you want to throw it in, any old universe will have life in it in the same way that any old hole could have a puddle in it, then that claim is just false. It's not analogous at all. It is not true that any old universe could have life in it. We can make universes where no two particles ever touch each other. In fact, those ones are remarkably easy to make. So again, this is one of those things where everyone has a different answer. Everyone has a different interpretation of the puddle analogy as well.
Yes.
So, around we go.
Yeah, that's what I was going to say. I think I'm starting to hear the number one objection now is there is no fine tuning. And the other is some variation of the anthropic principle, whether it's puddle analogy or something. We're here and we see it, and that's why we see it, and we know it. And I've even heard a couple try to say it's a Texas sharpshooter fallacy, and I'm like, I mean, just let's actually look at what's being argued here.
Yeah.
But anyway, yeah.
I've tried to. I thought this would be a good strategy of saying, all right, let's take a case. The sort of things some atheists say when you say, what would you take as evidence for God? They say something like, oh, I don't know, all the stars rearranged tomorrow night to spell out the first 14 verses of John chapter 1 or something. And then you sort of frame that argument. Okay, suppose that happens. Let's take the objection that you raised and apply it to that argument and see if it's any good. So the objection of, where do you get your probabilities from?
Right.
Okay, that's a really good question, and I think I have a reasonable answer to that, and we go into that a little bit in the book. But if the stars rearrange tomorrow night, and you said, okay, the probability of that happening if there's no God is extremely small. The probability of that happening if there is a God is not extremely small. It doesn't have to be large. It's not like we predicted that was going to happen, but it's a whole lot more likely than if there's no God. if someone stopped and went, "Oh, where are you getting these probabilities from?" We'd say, "Okay, that's a good question, but it shouldn't override the force of this argument, right?"
No.
If God then steps in and says, "Look, I wrote this stuff in the stars for you. Why didn't you then believe that I exist?" And you said, "Well, I didn't know where the probabilities came from. You needed to put your calculations next to the first 14 verses of John." That that wouldn't hold water, hopefully, with God. So I've been trying to use that sort of approach. I called it in a paper of mine, the awesome theological argument. However, someone I think it was on Twitter, just bit the bullet the other day. I was having a chat, and just said, "What if this happened?" And they were like, "No, I wouldn't accept that as evidence for God." Any evidence for God? No. Like, okay. You can't. I mean, Twitter is a cesspool anyway. But
it's yeah, I do. Yeah, I can't do Twitter.
At some point on Twitter, you just walk away and go, "Oh, well, you have fun."
Yeah, I hate okay, you got to put the 1 for this is reply 1, and then you got to put 2 because you're going to reply with 2, and I'm just like, I can't stand this.
I've had something where someone posts something sort of interesting and reasonable, and I post something like, "Oh, cool, where's your source for that? I want to read more about this." And then someone else will take issue with it, but they'll reply to my reply instead of their reply. And so I wake up tomorrow, the next day, and there's 50 notifications. I'm like, what happened? And someone started a fight, but they started off my comment instead of the original post.
Right.
Like, oh, okay. That's just... I can delete all those.
I don't know if you're on TikTok or not, but it's the same way. Somebody,
no, I've avoided TikTok until
somebody comments on my video, and then somebody replies to their comment, and then they get into a discussion, and I have 50 alerts because they've been going back and forth, and I'm like, this doesn't even have anything to do with me. So yeah, it definitely gets annoying. So yeah, that was I figured the anthropic principle was probably one you heard a lot about. So when you're just for those that are listening, so you actually lay out a Bayesian case for it, right? Mm-hmm. And you're comparing the hypothesis versus alternative hypothesis, right? Or the null hypothesis. And I think that's where people don't understand, like when you're, you have a set of 1, how are you doing a probability? And it's like, but that's not how Bayesian is done. It's not that we have a set of 1. You have your background knowledge, you have your evidences, and all of that goes into coming out with a probability. And it doesn't even have to be a high probability, as long as it's higher than competing hypothesis. So is that about the summary of where you're going with the probability?
Yeah. So roughly speaking, there's more advanced, widely applicable forms of probability theory than us, taught in high school. So I was taught in high school, as probably most people were, probability is favorable over possible. It's the number of outcomes you're interested in divided by the total number of outcomes. So the probability of rolling a 6 is, well, there's one side with a 6 on it, and there's 6 sides, so it's 1 in 6. And then the way you get probabilities is you just do lots and lots of repeats of the experiment, and you slowly build up probabilities. That is our view of probabilities, and it's a perfectly fine and valid one, but there's just a more general, broader framework which we call Bayesian probabilities. There's various reasons why it's called that. One of the great advantages of it, so in physics, for example, you want to answer a question like, okay, given all the evidence that I have, is it more likely that the planets in our solar system obey Newton's idea of gravity or Einstein's idea of gravity? Okay. The problem with that is there's no way you can interpret that question in that favorable over possible, let's count the outcomes kind of things. It's not like, every Tuesday it obeys Newton, and so there's sort of a 6 out of 7 chance that Einstein is the right answer. Or, we don't have a million different solar systems, and in 99% of them they obey Einstein, and in 1% they obey Newton, and so there's our preference for Einstein over Newton. So there must be a broader sense of probability if we're going to say things like, it is much more like, given what we know, it is much more likely that the law of gravity that operates in the solar system is Einstein's law, not Newton's law. So this broader sense is just that. It's really trying, and a good place to start, a textbook by someone called Edwin Jaynes, Jaynes, called Probability Theory, The Logic of Science. It's trying to extend logic. So in logic, you have this premise and that premise, and together they prove another premise. And what probability is trying to say, okay, this premise and that premise, they make this other premise more likely or less likely or probable or improbable or something like that. So it's not a black and white, this is true, that is true, therefore this is true. It's, this is true, that's true, therefore it's more likely that that's going to be the case. So, for example, the fact that it is currently cloudy outside certainly doesn't prove that it will rain later today, but it makes it more likely that it will rain later today compared if I looked outside and saw just completely blue skies. So it's those intermediate cases where evidence is bringing up and bringing down the probabilities of certain other ideas that Bayesian probability is designed to apply to.
Right. Yeah, I'm a fan of Bayesian myself, so it's I'm more of a probabilist in my epistemology, so it works out for me. So we're coming up on an hour, so now I'm going to hit you with the hard questions.
Smashing.
Do you prefer Star Wars or Star Trek?
Always a Star Wars guy. I just didn't get... just never got into Star Trek as a kid. I don't think it was on telly in Australia. Australian TV is a weird blend of the stuff from the US that they think will work out here and the UK. And Star Wars was on all the time, and Star Trek just was nowhere. So
okay,
Star Wars.
You picked the right one anyway.
Good.
I was born 1978, so it was right in the height of the original Star Wars, and we were just hooked as kids.
Perfect.
I did watch Star Trek. I just didn't get as big into it. What are your thoughts on astrology?
Depends what time of day it is. The weird thing is I've been teaching the course I do at Western Sydney called Scientific Literacy. And before, there's no clear break between astrology and astronomy in history. Certainly these days there is. But, the question of, you look at all these thinkers, and especially through the Middle Ages, where there's lots and lots of astronomy done, it's a complete myth that it's the Dark Ages.
Yeah.
But, why were they looking at the positions of the planets? Well, they had to keep an eye on the calendar, and, there've been all sorts of records and all these things. But also, there's still some people who thought that if you knew exactly where things were in the night sky, then you could work out what was going to happen in the future. And the problem is, I was saying this to the students, the idea that the heavenly bodies affect us is absolutely true for at least two of them, right? The sun and the moon. The moon controls the tides. And that's a really weird thing if you think about it for half a second, right? The moon, goes over there and suddenly the ocean rises. And if you think about that for long enough, it's not completely ridiculous to think, well, maybe if Mars is over there, that might affect something down here as well. It doesn't, but
Yeah,
You know,
that's
if you're trolling around, sort of looking around, trawling around for ideas about how the universe works, it's at least one to think about. And it does, because it could be really subtle. It's kind of hard to work out.
yeah.
Yeah. Anyway, but these days it's just pure, charlatans.
That's yeah. Oh, it never ceases to amaze me how many people read their horoscopes and actually draw from their horoscope, and it's like that is, first of all, they're always just vague enough to apply
Well,
to just about anybody.
here's the thing. Um, I think it almost works. It doesn't work for the reason they say. Here's the thing about the placebo effect. So the placebo effect in medicine is, the placebo effect in medicine is not, if you think you're getting medicine, you'll think you're getting better. That's not it. It's stronger than that. It's if you think you're getting medicine, you will actually get better. Right. And so there's something going on there. It's not a pure trick of the mind. Obviously, there's some trick of the mind there because there's no actual medicine. But I think there's something a bit like that. So if I told you every day this week, look out for an exciting new opportunity, and you believe that because Mars is over there or some nonsense, whatever. But if you just thought of that every day of the week, actually, if you live life like that, you might have a more exciting life. It's sort of the right answer for all the wrong reasons. So if we say Jupiter is overhead, so look after your mum this week. If you start doing that, you'll be like, oh yeah, I looked after this mum this week and it was really rewarding. Well, it had nothing to do with Jupiter, but it's actually not particularly bad advice. I have thought of making up, and someone was doing this for a while, I think it was on Twitter as well, of doing astrological predictions, but using the most advanced, there's a quasar over there, so watch out for your front tires.
Yeah, well, we're if there's a quasar where we can see it, we're in trouble. So yeah, definitely. So the last question is, can you think of maybe lately, maybe not too far back, of something that you did really embarrassing, like maybe giving a conference, mess something up, or?
Oh, I have put a I put a Nobel Prize winner to sleep in a talk at a conference once.
That takes the cake.
So the wonderful and venerable Brian Schmidt, who actually wrote the foreword to our book, is at the Australian National University, won the Nobel Prize, I think, in 2011 for his part in the discovery that the expansion of the universe is accelerating. Just the absolute top shelf of scientists. But we were at a conference. It was the Australian meeting of theoretical astrophysicists. He was there just to sort of launch us off. He's an observer himself, but he was there. He'd given his introductory talk. I think Lawrence Krauss was there as well. Yeah, he was. Yeah, anyway, he was in town. He's in Australia from time to time. He is a theoretical, cosmologist, so that was fine. Gave an interesting talk, and then I was on, I think, second, and I just spotted, as I was talking about my stuff, it was sort of galaxy formation related. It wasn't anything fine tuning, and I just saw Brian just do that. And I thought, there he goes. So I put a Nobel Prize winner to sleep. It was that moment, but that's now just in my head. I put a Nobel Prize winner to sleep.
That might be an accomplishment.
Well, it's just there in my psyche now. No, we've all done it in talks, right? So I don't. In no way do I want to criticize him, but that is something I've done.
Well, when I was younger, the art of looking awake while in church was hard practice. So I'm sure there's many important things that I missed along the way. Oh, yeah. Well, Dr. Luke Barnes, thank you so much for joining us. I am extremely humbled and thankful that you would come on here and spend some time with us. I want to respect your time and give you the rest of your day.
Well, thanks for having me. It was a good chat.
Oh, absolutely. Do you have anything coming up you want to plug, or any websites, books, or?
The other book that Geraint Lewis and I wrote is just there. It's called The Cosmic Revolutionaries Handbook. The origin of that is we kept getting emails from people telling us how to do our job. There's a whole bunch of people out there who have ideas about cosmology, that this Big Bang Theory, rubbish. And here's my idea, and it's loads better. I found that actually giving talks, if I say to an audience, do people just tell you how to do your job? And literally everyone goes, yeah, oh, absolutely they do.
Wow.
Doesn't matter who they are. And so it goes all the way from the top to the bottom. I have a friend who's an archaeologist, and people tell him how to do his job. But so what we wanted to do was basically say, all right, if you're going to tell us how to do our job, here's how to do it properly. Here's the evidence. Here's the evidence you've actually got to get your theory to explain. Here's how it's explained in the Big Bang Theory. Here is some evidence that actually isn't explained particularly well in the Big Bang Theory. But if you want to jump on top of that, you better explain all this other stuff first. You've got to buy your ticket to the show, right? Explain the basic stuff, and then you can start to look at the sort of mysteries that the Big Bang hasn't explained yet. So all of that's laid out as a look. If you want to overthrow the Big Bang Theory, here's how to do it. So that
yeah, absolutely. Yeah, that's definitely one I'll have to get. I've got your first book, so definitely have to pick up that one. I did see it when I was going through your information and everything, and I do have your website link below and your profile link for your school. I'm drawing like West Sydney, Western Sydney. Yeah. So thank you so much, Dr. Barnes. Have a good evening. Yeah, definitely. I'm going to see everybody out of here. Ooh, Dr. Luke Barnes, one of my favorite. From the fine tuning, when I first learned about it, and the cosmological constants and all these, kind of really thin areas that we can't move a whole lot out of, without having at least, carbon life. I was extremely intrigued by it. And there's not a whole lot of contemporary arguments for God that I find very convincing. Two of them would be the contingency argument and the fine-tuning argument. And then moral realism, I think, are three of the most convincing. But anyway, thank you, everybody, for joining us. For all of my podcast subscribers and those who's downloaded the podcast, I have gotten over 2,000 downloads. I hit the 2,000 mark last week. Thank you so much. It has been fantastic. It's at the rate of downloads, it puts my podcast in the top 25% of podcasters. So I'm super stoked about that. Thank you so much. And for everybody who joined us in the chat, I saw Neil, the 604 Atheist, Captain Dadpool, Jenna, my buddy Kyle was there. Oh, I even saw Cease to Know popped in. Titan, as usual. Thank you, Titan. Just Questions, Spartan Theology. Exploring Reality. Than, check out his channel too. There was Secular Rarity, my homeboy. Hey, my wife was in there too. At least I get some hometown love in there. So thank you, everybody, again. Have a good evening. Oh, wait a minute. First, December the 1st, which is ironically my birthday. I'll be 39 for the 5th time. I've got Greg Kokel from Stand to Reason coming on. He has his own radio show. He's an author, and in the apologetic circle, he is very, very well known, and he is a gentleman and just a super cool guy all the way around. So everybody have a good rest of the evening. Thanks again for joining us.